Hi, welcome back to my channel. Well, in this video, I will perform a demonstration regarding factorial CRD. Since in the previous video, I have performed the analysis of single factor CRD. Today, we are going to perform the factorial CRD analysis in JASP. Since this is a freely available open source software, how you are going to download it, I have already given the description in my previous video along with the link from which you can download it. So very quickly, let us click on this so that we can import the data. So we'll click on this open. Then since my data set is stored on my desktop, I will click on this desktop. Name of my data set is FCRD. Then I will click on this open. So this data set will get imported. Make sure your data set is stored in the CSV file. So here we have a data set. We have two factors, shade, spacing, and we have some continuous variables. So in case of shade, I have 4 levels. In case of spacing, we have 3 levels. So how we are going to perform this CRD in a factorial setup? So we will click on this ANOVA, and in classical category, we will click on this ANOVA. Then we will start with the first dependent variable. I will click on this. Then one by one, I will put them factors in this fixed factor column. The second one is spacing. So this ANOVA will get displayed. Here we have 3 sources of variation apart from residuals or errors. The first one is the first factor, that is shade, which is significant, spacing, which is also significant, and here the interaction between these two factors is also found out to be significant. That means their individual as well their interaction effect is found out to be significant. Let us display their descriptive statistics. We will click on the descriptive statistics. So we have mean, standard deviation, standard error, and coefficient of variation for all these. Then after that, we can click on the estimates of the effective size to display neta square, partial neta square, omega square. Then after that, we can check the assumptions also, the homogeneity of the tests, homogeneity of the variances by means of Levin's test. Here we have a non-significant p-value for Levin's test, which indicates that there's an existence of homogeneity of variances of errors. So in order to display the normality by means of QQ plot, we will click on this QQ plot residuals. So we will get a QQ plot between the standard residuals and theoretical quantiles. Majority of the observations are along this red line. Then we'll perform the post hoc analysis. In order to perform the post hoc analysis, we will click on these factors one by one, including the interaction. Then what we have to do after that, once we are done with this, we'll click on this 2 keys, because by default it takes 2 keys, then display confidence level and flag significant comparisons. So here we have a post hoc test for the first factor, that is shade, and the second factor, that is spacing, and we have a post hoc comparison of interaction, that is between shade and spacing. And based on these p values, you can see whether there's a significant difference between the two levels. Say for example, whether there's a significant difference between the first level of shade with respect to the second level, with respect to the third level, and with respect to the fourth level. Similarly, in case of spacing and in case of this interaction, we can give our interpretation. So within few clicks, we can perform this factorial CRD in a very quicker time. And if you are interested to perform the analysis of another variable, let us take this one, LA. So we'll click on this. Here it can perform the analysis of another variable, and here you can find out this. In the second variable, we have a significant Levin's test. There is the non-existence of homogeneity of error variances, and our data is also not normally distributed. And you can find out that there's an that the interaction, there is a very there is an existence of interaction, there is an existence of significant difference, but as far as the assumptions of this analysis of variance concerned, they are being violated. So here what we have to do, we can use some transformations, adjustments, so that we can make adjustments and these assumptions are fulfilled. So as per the objectives, as per the unit or the scale of this variable, we can apply the transformation, and you can see some of the interactions are found out to be non-significant, some are significant. So we can perform the analysis of another variables also. Let us take an example of RF here, RFW, and here you can see all the results gets displayed. So the good thing is that within few clicks we can perform the basic analysis of variance in a factorial setup. In context of CRD, we don't need to do any kind of coding here. Hope you will like this video. Thank you very much.